Hello, Avalanche. My name is Chris Wilson, and in this tutorial, we will learn how to create, sign, and broadcast a simple transaction on Avalanche X Chain with DataHub. Go ahead and navigate over to your DataHub and click on Tutorial 4 under your Avalanche pathway. Now that we've got a basic knowledge on how to interact with the blockchain, but so far, we've only performed read operations. In this tutorial, we will learn how to create a simple transaction, sign, and broadcast them on the Avalanche network. Make sure you've completed the previous 3 tutorials before beginning this one, and we can go ahead and jump on into creating a transaction. We already know that Avalanche is not your typical blockchain. With PXC chains supporting various operations, each of these chains also has its own set of transaction types. However, we are looking to create a very simple one, a token transfer, and specifically on X-Chain. In layman's terms, we will be sending some AVAX tokens from address A to address B to simulate a payment for goods or services. Simple as that. Let's start by creating a new file, transfer.js, in our project. Let's go in here, create file, transfer.js. Now that we're in there, we can take this bit of code here, plop it in there, hit save. A few new imports in sight. Avalanche is the core Avalanche package. We already use it in the client.js file, but we'll need it for other things this time. Bin tools is a helper utility to perform encoding/decoding operations on certain data types, like base 58 strings. Init keychains. Just like in the second tutorial, creating account, we are going to load the private key into the keychain so we can create and sign the transaction. We can add the following code under init keychain, part of the main function. So let's copy that. Right in there, we can drop it and save. Nothing really new here. Moving on. Let's prepare the transaction. Next, before we can build a transaction, we need to find UTXOs for our address. What is a UTXO? A UTXO is an unspent transaction output in an accepted transaction in a valid blockchain payment system. Only unspent outputs can be used as inputs to a transaction. When a transaction takes place, inputs are deleted and outputs are created as new UTXOs. That may then be consumed in future transactions. Code from this section goes into number 2, prepare transaction, part of the main function. We can obtain the UTXOs with the following code. And save. These outputs will be used as inputs for our new transaction. Now let's prepare some details about the transaction. We can add this section right under there. And save. You can pick any X-Chain address as a receiver, including your own, though for testing purposes, we're also providing Figment's test address so you can track your progress. Transaction amount is 0.05 AVAX. Remember, AVAX asset is using a 9-digit denomination. AVAX is the primary asset on the X chain, so we'll be using that. Next step is to determine the real asset ID for symbol AVAX. We can do that by adding this bit of code and save. Because the following build-based transaction expects an ID instead of a symbol, we can even hard-code the asset ID into the code to reduce amount of API calls. Asset ID does not change after its creation. Still, we want to know how to properly translate a symbol into its ID. Bin tools helper does this conversion of raw response data into the base 58 coding format. Now is a good time to print out our current balance, so we can see any changes after our transaction is submitted. And save. We have everything we need to prepare our transaction. Generate new transaction. And save. At this point, our transaction is ready to be signed and broadcast to the network. Transaction builder method build base TX calculates transaction fees automatically. Now to send the transaction. A transaction does not really exist until it gets processed by the network. Before we can broadcast a transaction, it must be signed with a private key. The process of signing transactions is specific to each blockchain and can be rather technical. Here, we use Avalanche.js to condense it into a single line of code. Code from this line goes under number 3, send transaction to the network, part of the main function. Sign the transaction with this bit. That's it. We're ready to broadcast the transaction. Let's add the broadcast bit. There we go. Save. Avalanche has a very short transaction finality time frame, that is, how fast a transaction is approved, usually within seconds, which makes it great for almost real-time payment processing. Next, we'll check if our transaction gets accepted. We can add this bit below where we were just at. And save. We're checking the transaction status, waiting a short amount of time, updating the transaction status, and finally displaying the balance. When the transaction is accepted and confirmed, you will see the status change to accepted and the balance updated. Time to see our code in action. We can do so by entering nodetransfer.js into our terminal and hitting enter. Awesome, there it is. Here's the example output, and here that's exactly what we got. Everything worked out so far. You can check the provided Explorer link to see all transaction details by clicking that link. And there it is. Awesome. Look at the before-after balances. We can determine the transaction fee from calculation, fee amount, or 0.001 AVX. We already know the base transaction fee from the previous tutorial. Congratulations! We've learned how to prepare, sign, and broadcast a simple transaction on Avalanche. With basically a few lines of code, you can transfer funds on the network. Though Avalanche.js provides a wide range of examples on how to construct a transaction with a bit more complex properties for different use cases, you can see examples on the GitHub. Don't forget to go to the Data Hub and verify you've completed the step. And that concludes tutorial number 4. Join us next time for our next topic is the cross-chain transfers. Since Avalanche operates on 3 chains, XPC, it allows users to transfer tokens in each direction. We'll be concentrating our efforts on X to C swaps and C chain being used for smart contract deployments. As always, if you had any difficulty following this tutorial or simply want to discuss Avalanche and Data Hub tech, you can join our Discord in the link down below. I look forward to seeing you there, and until next time, happy coding.